Our group studied the impact that various consumer traits have on the amount of money that they will spend. We chose to do an exploratory observational study where we sought to determine which factors are the most influential in determining how much a customer will spend on products. And the motivation with this is because knowing which factors are most influential can determine where companies put their efforts in advertising and can improve the profits that the companies have. Next, we're going to talk about the justifications for some of the predictors we had included. So for instance, income, mostly intuitive. The more money a person has, the more they'll spend. Complaining, if somebody complains, then they might be unhappy. The number of children that a family has also might matter. Children and teenagers, just because as they have a larger family size, they might spend more. The amount they spend online also matters, well, online, in-store, and in a catalog, because that way the company can know where they put their advertising money as well. And lastly, we also included education level, just because it could be the case that different people of higher or lower education spend differently, and so that might be good to know. So our general question is, how do customer traits affect the amount spent on goods? Getting to our specific questions, though, the first question we went over is there a difference in the effective income on the amount spent between people who complain and those who do not? So our X variables are income, which is continuous, and complaining, which is categorical. And so you can see the reduced models and the full model, and we're basically just trying to see the factor effect of beta 1, 2 on Y, if it's 0 or not 0. So the final model we had an R-squared value of 0.793, which is pretty good, and it had a very low RMSE. And the hypothesis test gave us a F statistic of 3.8, which when we computed the F statistic for the model, we got 0.08, so that translates to a p-value of 0.776. So we can conclude that because this p-value is much greater than 0.05, we should not reject the null hypothesis and conclude that there is no effect on income that complaining has. And so as such, companies shouldn't change their marketing strategies depending on income, depending on if somebody complains or not. Moving on to some diagnostics for this model, just looking at the scatter plots, it doesn't look very linear. In fact, it looks exponential, and the residuals have that weird line, that weird cutoff. So it fails the linearity check. Normality, the QQ plot and the Shapiro test both indicate that the errors are not normal. In addition, the Brown-Forsyth test indicates that the variance is not equivalent as either, and the collinearity of all of the variables is good according to the VIF test. So they're not collinear, but the constant variance has failed. In addition to diagnostics, just looking at the outliers and influence points, there are a lot of outliers on X and Y values, and there are a couple instances of influence points on fitted values and betas, as you can see from these graphs. So fixing the linearity, we did the Box-Cox procedure and we found a lambda of 0.27, and when we transformed Y, which we didn't transform Y because transforming X didn't work, but you can see the before and after results. They look much better and definitely more linear than before. We also pruned all of the outliers out of the data set, so you can see before and after there appear to be much less outliers, and the data points seem to be much more evenly spread out afterwards. In addition to the simple remedies outlined above or before, we also tried advanced remedies such as weighted least squares regression and robust regression, as well as, or in addition to the OLS. And we found that most of the models performed about equivalently, with WLS being slightly higher F statistic, but having worse RSE. And so we just went with the OLS model because has a lower standard error and about the same R-squared and F statistic.
Company XYZ has many platforms where they do their sales. So they have a website, they have catalogs that they ship out to their subscribers, as well as in-person stores. And one thing that the marketing team can really benefit from is what kind of people shop where. So one key factor that we want to tie in to the different platforms would be income. So question 2 entails, does income of each customer have any significant linear impact on where they do their shopping? So X1 is going to be our website, X2 is going to be the catalogs, and then X3 is going to be our in-store purchases. And as you can see, we formulated these into our reduced model, full model, and our in summary modeled, having an R square of 0.362. And as we move forward, we're going to begin the diagnostics of this question. As we set up our null hypothesis and our alternative hypothesis in the previous slide, here we run the ANOVA tests and the summary in R, and we're able to see that the p-value is significantly lower than our assumed alpha of 0.05 or 5%. So we can say after this series of tests, we conclude that we can reject our null hypothesis, and there is some sort of significance, linear significance between income and where shoppers tend to do their shopping. And as we move forward, we will go in depth and see as to why this test came out the way it is. So we'll touch on all the major tests from R along the semester. Moving right along into our model building, we wanted to answer the 3 basic tests here, which is test of linearity, normality, and a constant variance. So with linearity, you can see from the middle graph, looking at our residuals versus fitted values there, the values are a little expanded towards the right, but it is safe to say that it's nothing too extreme. And then also looking at the far right column, we can see that when it's zoomed out like that, we have a straight line mostly at 0. So we made the assumption to say that the linearity test was passed, that this maintains linearity. Normality, on the other hand, the QQ test was normal, but it curved out at the end, which was fine. That lines up with our linearity assumptions. But the Shapiro test did not pass. So we went ahead and said that normality is not present. And as for the constant variance, that is a pass as well. The p-value is quite large compared to the alpha of 0.05 here. So we went ahead and just said that that constant variance is intact here. Moving on to the tests that determine the outliers and the influential points on coefficients, we found that there were a few extreme outliers on X and Y. There weren't any subtle influential cases of these outliers, so I felt no need to remove them. Just being able to zoom in to the chart in R, and it's the exact same thing. Moving on to the degrees of freedoms on the Betas plots, there were no influential points on those coefficients.
Hi, my name is Lei, and I'm responsible for research question 3, which is, does the number of children, X2, and teenagers, X3, in the household of XYZ's customers have a significant impact on their expenditure after accounting for income, X1? The reason we account for income is that income may already indicate the number of children and teenagers in each household. So, our null hypothesis is that beta 2 equals to beta 3 equals to 0. So that would mean our reduced model is y equals to beta 0 plus beta 1 times x1. And our degree of freedom for that would be 2019. For our alternate hypothesis, it's that beta 2 is not 0 and beta 3 is not 0, which would mean our full model is y equals beta 0 plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3, giving us a degree of freedom of 2017. And we conclude that we're able to reject the null hypothesis and that the number of children and teenagers in the household has a significant linear impact on the household's expenditure. This is because the one-way ANOVA shows both variables are significant, and as you can see, their p-values are extremely low, lower than the significance level. We also did a two-way ANOVA to compare the reduced and full model, and it was able to show that they're also significantly different. And as you can see, our full model was able to achieve an RMSE of 315, an R-square of 0.72, and an MAE of 241 with tenfold cross-validation. Here we test the linearity, normality, constant variance, and multicollinearity assumptions of our model. For linearity, we plotted the residual plots against each predictor, and as you can see, they're centered around 0, indicating a linear model is appropriate. For normality, we plotted a QQ plot of our residuals, which shows that our residuals are mostly normal except for the tail values. We also did Shapiro's Wilk test that gave us an extremely low p-value, indicating the residuals are not normal. We also did a Brown-Forsyth test with 3 groups because our x2 and x3 variables can be separated into 3 groups, which gave us a extremely low p-value, which also indicates our residuals do not have constant variance. For multicollinearity, we calculated the variance inflation factor for each combination of variables, and they all gave extremely low values, so there is no multicollinearity. Here we tested the data for outliers. We made an influence plot, a DF-Betas plot, and a Cook's distance plot, and the outlier bounds are shown above. As you can see, there are outliers on X and Y, and there are minor influential cases. Based on our issues of non-constant error variance and outliers, we performed weighted least squares and robust regression on the data with the outliers removed. As you can see, both weighted least squares and robust regression provide tighter confidence intervals for the estimated parameters. We can also see robust regression provide a lower residual standard error over ordinary least squares.
Hi, my name is Bryce Jordan, and I did research question 4 for our group. My question is, does the way of purchase, such as web purchase, our X1 predictor, catalog purchase, my X2 predictor, and store purchase, my X3 predictor, have a significant linear impact on the dollars each customer spent in the last 2 years, which is my Y predictor? As you can see, my reduced model is testing if my betas for web purchase, catalog purchase, and store purchase are all equal to 0. Therefore, my reduced model is y equal to beta 0 plus the random error in the model. And the degrees of freedom for error in our reduced model is 20/20. Whereas my full model is stating that the betas for web purchase, catalog purchase, and store purchase are not equal to 0. Therefore, my full model includes y equal to beta 0 plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3 plus the random error of the model. And the degrees of freedom for error in the full model is 2017. Also, from the ANOVA test we conducted, we can see that our R squared is 0.7264, indicating that the variation in our Y is explained by approximately 73% by our X predictors through a linear model. Also, because at least one of our predictors is potentially useful in predicting Y, since the p-values in this case for all predictors is less than our significant level of 0.05, we reject the null hypothesis and conclude that the web purchase, catalog purchase, and store purchase have a significant linear impact on the dollars each customer spent in the last 2 years. In this slide, we tested the linearity, normality, constant variance, and multicollinearity of our full model. For linearity, we generated a residual plot for each predictor and found that the residuals fall between the bands centered around 0, thus providing evidence that the use of a linear model can be reasonable. To test normality, we used a QQ plot and the Shapiro test. The shape of the QQ plot did not resemble the shape of a model with normally distributed residuals, and we confirmed this assumption by the Shapiro test, which showed a p-value equal to approximately 0, which is less than our alpha of 0.05. Thus, the residuals in the dataset are not normally distributed. Next, we conducted a test on constant variance through the Brown-Forsyth test, which also showed a p-value of approximately 0, which is less than our alpha value of 0.05, and therefore the variance of the error terms are not constant in the model. Finally, for our multicollinearity test, we tested the variance inflation factor of the model in different orders for the predictors. The different order of the predictors in the model yield a result of a VIF value of 6.619404, which is less than 10, and therefore there is not an issue of multicollinearity in the model. On this slide, we can see that the HAP matrix, HII, is greater than 2 times P over N, therefore indicating that there are extreme outliers on X. For the Cook's distance, we found the boundaries to be 0.4121583 and 0.8394558 for the 20th and 50th percentile respectively. And therefore we can see that there is a value in between those two, therefore indicating minor influential cases. Next, for the DF betas, we found that the DF betas is less than 1, therefore there are no influential points on beta. For the last slide in my research question, we are comparing the OLS and the WLS models. Between the two models, we can see the standard error of the coefficients are smaller, and the multiple R squared and the F statistic are larger. This is most likely because the heteroscedasticity in the errors is accounted for by our chosen weighting scheme. On this slide, we are also comparing the OLS model with the robust regression model. From the comparison, we can see the residual standard error of the robust model is 74.82, which is less than that of the OLS model residual standard error of 315.3. Therefore indicating that the model needs to use the robust regression and WLS models together because it appears our model is influenced by outliers and other observations, and is also experiencing an issue with heteroscedasticity as well.
Hi, I'm Marcus Gojihua, and I'll be presenting question 5. So the problem statement for this question is, to improve sales, a common approach is to identify and ensure that the best-selling product continues to garner more sales. Does the type of platform have an effect on the impact of the number of best-selling products sold? So firstly, wine is clearly the best seller, with the most amount of money spent on it in the past 2 years as compared to the other products. The hypotheses and models are as shown on the screen. So amount of wine is a dependable variable, and web purchases, num deals, catalog purchases, and as well as number of store purchases are the platforms. So presence for heteroscedasticity in the dataset was found by the Bruce-Pagan test as well as residual plot, and normality of errors were checked to be violated by the Shapiro test and normal QQ plot. And lastly, multicollinearity was not found to be present or significant in the dataset. So next, removal of outliers using the Bonferroni procedure studentized deleted residual as well as head matrix leverage values were used, and as well as for influential points, DFFITS, Cook's distance, and DFBTS were used. And it can be seen that from the original model, after removing outliers and influential points, the model actually improved significantly as shown on the bottom right with the different metrics shown. Even after trying to transform y to square root, as well as using logarithm to transform y, the assumptions were still violated. So I used weighted least squares as well as robust regressions to try to tackle heteroscedasticity and outliers respectively. Select the optimal model. Metrics like R-square adjusted, root mean square error, AIC, and BIC, as well as model validation using k-fold cross-validation were used. And as it can be seen, weighted least squares with square root transform y is the model selected. Thereafter, using bootstrap to obtain the confidence intervals of the various betas. And so as it can be seen, all of the predictors had a significant relationship with how much the customer spends on wine in the past 2 years. Except, if you notice, num deals purchases, which is the x2 variable, is actually negative, and this does not really make sense since money spent on wine can only be positive. And just to take note, for interpretation, as y was transformed using square root, this means that for an increase of 1 unit of num web purchases, square root amount of money spent on wine increases by a range of 1.365 to 1.511. So in a nutshell, for question 1, it appears that whether or not someone complains does not change the effect that income has on the amount spent on the company. Question 2, shoppers' income does not have a significant linear impact on where they choose to do their shopping. Question 3, the number of children and teenagers in the household has a significant linear impact on spending. Question 4, web purchases, catalog purchases, and store purchases have a significant linear impact on the dollars each customer spent in the last 3 years. And lastly, question 5, the 3 types of platform, catalog, website, store, does have a significant linear impact with the sales of the company's bestseller product, which is wine, while discounts does not have a conclusive linear impact. And that's all Group 3 has with our study on consumer purchasing decisions and preferences for products for a company. Thank you.